Imagine this. You step into a spaceship, the engine ignites, and within seconds you reach the speed of light. But something strange happens. Everything around you begins to warp. The entire universe seems to be pulled into a tunnel ahead of you. The stars vanish behind you. Time stops. You feel nothing. Passing there was no yesterday. There will be no tomorrow. There is only now, frozen eternal, silent. That's exactly what would happen if you could travel at the speed of light. And no, this isn't science fiction. This is what physics actually predicts. In this video you'll understand why time would cease to exist, how space would contract before your eyes, and why everything would appear to bend around you. But first, let's take a step into this impossible journey and discover what you would really see if you could cross the cosmos like a beast of light. At the speed of light, the rules completely change. You look out the ship's window and see space folding before you. Galaxies that once seemed distant now appear crushed into your field of view. Everything compresses, everything stretches, everything seems to be rushing backward at an indescribable speed. But the strangest part isn't what you see, it's what you feel. Nothing, no passage of time, no sense of motion. It's as if the entire universe had been compressed into a single instant. Because from the perspective of someone traveling at the speed of light, time simply doesn't exist. Yes, you heard that right, time disappears. That 2.5 million light-year journey to Andromeda, for anyone else it would take millions of years. But for you traveling like a photon, that time would be exactly 0 seconds. You leave one point and arrive at the other instantly. This happens because in Einstein's physics, the faster you move, the more time slows down for you. And at the speed of light, it stops completely. It's the absolute limit of reality, a point where the very idea of before and after no longer makes any sense. While time is frozen for you, the space ahead compresses violently. Imagine this, the Andromeda galaxy, which is 2.5 million light-years from Earth, now feels like it's almost within arm's reach. Everything in the direction of your travel seems to move closer, flatten, shrink. There's a name for this length contraction. Einstein's relativity predicts that as you approach the speed of light, space in the direction of your movement shrinks dramatically. It's not an illusion, it's space itself being warped by your motion. And with time still frozen, you don't age. No seconds are ticking by. From your perspective, the journey is instantaneous, but here's a curious detail. For anyone outside the ship, time keeps flowing normally. From the outside, it would still take millions of years for you to reach your destination. But inside the ship, none of that happens. It's as if you've tricked time and bent space. Are you still moving? Technically, yes, but in practice, it feels more like the entire universe is sliding toward you, compressed, distorted, and silent. Now that time has stopped and space has shrunk, here comes the inevitable question. What would you actually see with your own eyes? The answer is something completely alien. Your field of vision would be extremely distorted due to a phenomenon called relativistic aberration. Your field of vision would be extremely distorted due to a phenomenon called relativistic aberration. The entire universe would appear to be pushed into a narrow tunnel in front of you, as if you were looking through a funnel of light. The stars around you would vanish from your side view and collapse into a central, bright, crushed point ahead. And that's not all. The colors would change drastically. Due to the relativistic Doppler effect, visible light would shift toward shorter and shorter wavelengths. What was once red turns blue, and blue becomes ultraviolet or even gamma rays. In other words, what you'd see likely wouldn't even be visible to your human eyes anymore. Your vision would grow darker and more distorted until eventually, all that's left is an intense, compressed glow in front of you, while the rest of the universe fades into the sides. The truth is, even if traveling at this speed were possible, no one would be able to see the universe as it truly is, because reality itself would be bent around you. Now imagine that after racing across the cosmos at the speed of light, you decide to slow down. The ship decelerates, time begins to return, and then you look around but the world you once knew is no longer there. Millions of years have passed, civilizations have risen and vanished, stars have died, planets have shifted places. All of this happened while you barely felt time go by. That's the brutal consequence of relativity. The time you ignored was still flowing out there. It's called the time paradox. While everything felt instantaneous to you, your journey took an eternity for the rest of the universe. You return, but to a distant future, a time you never lived, yet one that moved forward while you were frozen in your own pace. And here's the most shocking part: you didn't need a time machine, you just needed to accelerate. All of this sounds like science fiction, but believe it or not, relativity is already affecting your life right now, every single day. All of this sounds like science fiction, but believe it or not, relativity is already affecting your life right now, every single day. Want an example? The GPS on your phone only works correctly because the satellites account for time dilation effects. They're moving quickly in orbit and are farther from Earth's gravitational field. If those satellite clocks weren't adjusted based on Einstein's theory of relativity, location errors would pile up within minutes, and you'd get lost trying to find the bakery around the corner. Another example. Someone who flies frequently experiences time slightly differently than someone on the ground. The difference is tiny, but it's real and measurable with sensitive equipment. In other words, relativity isn't just an elegant theory, it's embedded in everyday technologies, in navigation systems, in space exploration, and in how we understand time itself. But after all, why does all of this happen? Why does time slow down, space compress, and reality seem to bend in the face of light? It all revolves around a single principle. The speed of light is constant and absolute for all observers, in any situation. This idea, proposed by Einstein in the early 20th century, forever changed the way we understand the universe. Whether you're standing still, running, flying, or traveling on a ship at insane speeds, light will always move at the exact same speed relative to you, 299,792,458 meters per second. But for that constancy to be preserved, something has to give, and what bends is time and space. If you try to move faster, the universe responds, time slows down for you, and distances shrink. It's a kind of cosmic compensation, a perfect mathematical dance where space and time adjust so that light always remains the same. That's why no one can surpass the speed of light, because the faster you try to go, the more time slows down, and when you reach the speed of light, if that were even possible, time simply disappears. Light isn't just a speed, it's the very limit of the universe itself. Now comes the inevitable part. You will never be a photon, and honestly, it's better that way. Now comes the inevitable part. You will never be a photon, and honestly, it's better that way. Photons have no mass. They don't age, they have no consciousness, no past, no future. From the perspective of light, the entire universe happens in a single frozen instant. Trying to imagine what light sees or feels is like trying to explain the taste of water to a rock. It makes no physical sense. That's why in practice, talking about time and space at the speed of light is like trying to divide 0 by 0. Math breaks down, physics collapses, and our references stop making sense. Light doesn't experience time, it doesn't travel, it simply is. And even if you could reach that speed, everything that defines your existence, thought, perception, memory, would cease to make sense. In that frozen state of reality, you wouldn't be traveling, you would cease to be. In the end, what this impossible journey reveals is something profound. Time is not absolute, but light is. Our idea of time as something constant, flowing equally for everyone, is a comfortable illusion shattered by relativity. Time is flexible, malleable, sensitive to speed and gravity. It can stretch, shrink, or even freeze depending on how you move through the universe. But light remains unchanged. It is the fixed point, the unbreakable limit, the ruler by which the universe measures itself. It's as if the universe were saying, you can change everything, time, space, distance, but light remains unaltered. And that's why this journey, as impossible as it may be, helps us see the world differently. Because this isn't just about physics. It's about how reality works in the strangest depths of the cosmos. Thank you so much, and I'll see you in the next one.